what we are going to discuss in this chapter, we're discussing cryptography, which actually makes sure the techniques and confidentiality which achieve the confidentiality. Okay. Yeah. Cryptography, access control, describe how access control used to protect the confidentiality of securing the data, describe the concept of securing the data. So what is a cryptography? Cryptography is a science of, this is a very huge topic actually. People do PhD or so many things in the cryptography. It's a science of making and breaking secret code. So making and breaking. So first of all, that's why it happened. Encrypting and de-encrypting. Cryptography is a way to store and transit the data so only the intended recipient can read or process it. Modern cryptography uses computationally secure algorithm to make sure that cyber criminal cannot easily protect the information. So history of cryptography started in diplomatic circulates thousands of years back. Messenger from king code took encrypted message to the other code. Occasionally the other code do involve in the communication, attempt to steal message sent to the kingdom. And yeah, I think I recently watched, again, maybe a movie example. I know the guy who actually, he was in the World War II. There was a German, when the World War II happening between UK and Germans was attacking here. And that's the time when actually computer was invented. Long time ago, but this is really when the computer. So the message sent by Germans government to their spy or others, actually, it need to be de-encrypted. So that guy, he invented a machine to actually de-encrypt that. So there was separate languages which was very difficult to read. I don't know the name of actually that movie, but it was very interesting to find out. Okay, so each encrypted method uses a specific algorithm called cipher. Okay, to encrypt and de-encrypt the message, a cipher is a series of well-defined steps used to encrypt and de-encrypt the message. There are several cipher text: transposition, substitution, and one-time pad. Okay, so these are what is a cipher actually? Each encrypted method uses a specific algorithm. So whatever the algorithm you're using called cipher. Okay, whenever you want to encrypt anything, you need to use particular algorithm or a cipher to encrypt and de-encrypt the message. So the person who is encrypted the message, if he use particular protocol, the other party who need to understand and verify the same protocol as well in order to de-encrypt the message. And these are the several creating cybertext: transposition, substitution, one-time pad. Cryptography overview: two types of encryption. There are two classifications of the encryption algorithm: symmetric algorithm and asymmetric algorithm. And we use them in a different way as well. So what is a symmetric algorithm? In symmetric algorithm, you can see we have a plain text. We use one key, and that is a shared key between the two parties. Both parties have the same key, one key. So if I want to open the door, okay, you have the same key, you can open it. Okay. So similarly, if I use one key to encrypt the message, the other party has the same key, okay, to de-encrypt the message, then he can read that message. This is the ciphertext. Ciphertext means whatever the plain text was, you taken that, you use the key, you encrypt that message, and then this message is a ciphertext, mean it is in unreadable format. If the person read this message, he will never be able to understand. This algorithm using this pre-shared key. Pre-shared key mean me and Ajesh want to exchange some information. We already know what key I'm using. You already know what key I'm using. It may be a number, it may be a text, anything. Sometimes call the shared pair key to encrypt and de-encrypt the data. Both the sender and receiver know the pre-shared key before any encrypted communication begin. So communication has not just started. We already exchanged the method before we know that what method you're using. So symmetric key is very, very straightforward. We just, before we need to agree on some kind of key, one key, just one key. Okay. What is asymmetrical algorithm? So in the asymmetrical algorithm, yes, you are doing encryption and decryption, but actually you are using the two keys. Okay. Mostly with that will be a separate discussion of long, maybe more than 1 hour chapter. We will discuss about public, private, infrastructure, PKI, certificate, symmetric, all these information, right? So don't worry. At this level, we just need to understand those. Asymmetric key algorithm uses one key to encrypt data and different key to de-encrypt the data. Okay? One key is public and the other key is private. In the public key encryption system, any person can de-encrypt the message using the public key of the receiver public key. And receiver is only one that can de-encrypt using the private key. So party exchange the secure message without needing a pre-shared key. So they do not actually share any pre-shared key before, like in the previous symmetrical. Asymmetric algorithms are more complex. These algorithms are more intensive, resource intensive, and slower to execute because there are a lot of mathematical calculation happen behind the scene. So the key concept is here, and that's maybe a tricky interview and exam question. Number one. So first of all, asymmetric keys use two keys. One to encrypt and the other to de-encrypt.
Yeah, Mother, can you give example of asymmetric?
Sorry?
Can you explain us with example? What is example? If you can give example in layman.
As I said, there will be a separate complete topic and discussion about public private key discussion. Okay, PKI, we call it PKI. So that will be completely used. We have at least 1 to 1.5 hour topic on that item in detail. As of now, just understand what is asymmetric algorithm and what is the difference between symmetric and asymmetric algorithm. So if somebody
Mother, we got this one. I'm just asking a general example.
General example is the best use cases is you using internet banking.
Yeah.
You're using the PayPal website. You're using eBay. You're using all these website information is HTTPS.
Yes.
They use public key infrastructure or they use asymmetric algorithm. That's all for the time being. Okay. In detail, what is happening, we'll discuss in detail each and everything. Okay, but the two key things which mostly we get confused with. So number two key, one to encrypt. You can see if I get the message plain text, I will encrypt with my one public key. I will use the public key. So they only share each other public key. They do not share the private key. Private key, my private key is different, your private key is different. But your public key and my public key will be exchanged with each other. I will use in a public key encryption system, one person can encrypt the message using public key. So if I have your public key, okay, I will encrypt the message, send it to you. You will use your own private key, okay, and your own public key to de-encrypt the message. De-encrypt. If you want to read the message, you need to use your private key. So that's what he's saying.
Mother, the public key will be the same between both the candidates. The public key will remain the same, but the private keys are different.
Okay. So
if I'm not wrong.
Yes. Sorry. One key is a public and the other is a private. In the public key encryption system, any person can encrypt the message using the public key. Yes, any person. Yes, you're right. So any public can use the public key of the receiver. So maybe the interviewer will ask you how it will be using its own public key or receiver public key. So you will be using the receiver public key. And the receiver is the only person, only one that can de-encrypt by using the private key. So if he want to read the message, he will using his own private key. Party exchange the secure messages without needing a pre-shared key. Asymmetric algorithms are more complex, these algorithms are used. So let me just give you one example here. Okay, this certificate, for example. Look at this certificate. And in the certificate, so we'll discuss this certificate in detail. Let me see the public key, I think. Look at this. Have a look. That is the public key. Okay. So you have the public key of the Google, for example. Okay. So I am exchanging, I am the client. I open this website. Okay. Sorry, 1 second. Just one minute. Yeah. So I have the key, I have the certificate. That certificate is for identity verification, but you can see this certificate has the public key parameter. Okay. Key exchange, identity subjects. Okay. This is the public key which will be exchanged over the internet. That's the one. And you can copy this as well. Okay. So basically, this is the public key. Now I have the public key of the receiver, and I can use the public key to encrypt the message. Okay.
So, Mother, we can say that asymmetric method is more secure than symmetric.
Absolutely, absolutely. Crack on. Yes, you're right. Absolutely,
and even if somebody, even if somebody sniffs the packet like a public key, they're gonna decrypt it because we have our own private keys.
Yes. So the private key never shared. We only share the public key over the internet. And if somebody has a public key, he cannot derive any private key from it. Because private key will never share. We don't share the information of the private key. Okay? So that's the difference you need to know. Private key encryption, symmetric process, asymmetric process using private key. The method is also known private key encryption. Like, okay, some of the common encryption standard. These are the standard we use. Symmetric encryption, including the following: DES, IDA, and AES. These are the DES or triple DES. I think DES is almost gone, or triple DES. So DES, I think the key length, this is the length of the key. We'll discuss in detail later on. But as of now, you just need to understand. So what is a DES? I think if you see, this is the is a 56 bit. If you multiply 3 times, okay. So this is the triple DES. Okay, 1 key, 2 key, 3. 56, 56, 56. So total length of the key is 168 bits. If you want to de-encrypt that, so some of the mechanisms are available. They can actually de-encrypt that. I think 56 bits is almost gone, which is DES. We call it DES actually. Mostly companies they are stopped using DES now because that was hacked, that was de-encrypted, I think, in the past. So DES is a symmetric block cipher with the 64-bit block size that uses the 56-bit key. Triple DES encrypts the data 3 times and uses a different key for the least one of the 3 passing, give it the cumulative size of 168. So basically, the longer the length of the key, more difficult to crack it. That's the international data encryption algorithm. 64-bit block and 128-bit. Idea was replacement for the DES, and now PGP uses it. So PGP is, what is PGP? We discussed in today. AES, Advanced Encryption Standard. So you see the AES is actually up to 256 bits. So while the maximum length of the triple DES is 168. No, 168. Yeah, 168 is the maximum length of the, yeah, you can see maximum length of 3 DES. So the next one is difficult to crack, which is AES, is another protocol. AES fixed blocks of 128 key with the key size of, so different key size you can use. When you configure that, when you will see this configure on the firewall later on, you will see that different key size.
Mother, can I ask you a question?
Yeah.
If you don't mind, please, yeah.
Please.
Why they have given us the bits 128, 192, 256? Why they are like pre-standard of AES?
Yeah, interesting, because the thing is, depending upon the, as you know, the longer the key length is, it will difficult to crack, and most importantly, it take more CPU utilization and resources, because the calculation will be more difficult for even the encryption and decryption. So the idea is, let's say you have a router or a firewall or whatever the device you are using. If it's not very big enough in terms of resources, CPU utilization and all those things, so they have given you the option. You can start with 128 bit, 192, 256. If you have a good enough resourceful firewall or a device, you can maybe use 256 bit. So they have given you different option.
So mother, or on the in a company as a consultant,
Yeah.
like who make this decision? Like we have to use 256 bit,
Both the party.
192.
Good question. Both the party they decide. Let's say I will propose 128. Others say no, sorry, we only use 192. So then I have to use 192 as well. Okay. So and it depends upon the size of the device, or the I would say model of the device. How resourceful is that? I would say.
Okay, mother, sorry, I want this class to be interactive.
For example, let me tell you. Let's say there is a router of 2600 router. Okay, which is almost no more longer in the network, and there is a router of maybe new CSR, ASR router, the latest one. So of course, if that router may be 10 years old, it may not even support maybe 128 bit. Then we have to use the DES 56 bits, for example. But if the company say we can't support 56 anymore, we need to use minimum 120. It's a company policy. That is defined by the information security person. They will write these policy that, okay, if you want to establish a VPN or any public key, private key infrastructure, this would be the minimum length. However, if the longer the length they would like to use, then they need to buy they need to put more money on the hardware side as well. Because the longer the...
Mother, I have a question now. When we are talking about the device, now the cloud has come now. So everything can go on a cloud. So, and we can pay money, pay as you go model we have about AWS or Azure. So all we can do configuration on the cloud as well. Do we have these keys as well?
Yeah, same thing. The standards are same. Whether you are configuring firewall, router, switch, or server, let's say you install a Windows 10 on a machine in the cloud, the commands or the graphical interface is the same. The only thing is that computer is not in your premises, it's somewhere else premises. So everything is same. The standards are never changed. But maybe because they are VM type of devices, they might have some restriction in terms of performance. Because if you use longer the key length you use, it can degrade the performance of the device as well. Okay, so that is the design decision, which key length you will be using. Thank you for discussing that. I really like that. But this is more like a design decision actually. So if you want to use 256, that's fine. But your hardware must be able to support that. Yeah, your hardware must be, let's say you use 256 and your CPU utilization goes to 100%. It means that there is no point using 256.
Yeah.
Okay. So it's approved by the NEST AE in December 2001. Public key infrastructure, asymmetric encryption process. Asymmetric encryption, also called public key infrastructure, using the same key which we already discussed. Criminal cannot calculate the decryption key based on the knowledge of the encryption key, and vice versa in many reasonable amount of time. The asymmetric algorithm include the RSA, Diffie-Hellman, and EIGMAL, I think. EIGMAL, right? Okay? Yeah. IGMAL, right? Elliptic. 4. These are the public key infrastructure. RSA, that's more likely the popular. Two are very popular. So let's see what of them. RSA, for example, this is the the one scientist, he actually explained this about the public key infrastructure, public and private key infrastructure. Okay, so they are using they take the plain text and they convert in the ciphertext, they exchange on the other side. This is the encryption key, public encryption, and de-encryption. If you want to de-encrypt that, I'm using my own private key. That private key will never share. So there are two keys, that's what they shown here. Sender and receiver, they share the public key with each other. If I want to encrypt anything, I will be using receiver public key, not my public key. Okay, then once he received that, he will be using his own private key and de-encrypt it. Browser uses RSA to establish a secure connection. That's fine. Diffie-Hellman is another most likely we use. Provide an electronic exchange method to share the secret key. Okay, now, you know, if we use a shared secret, for example, shared secret, we'll be using, let's say, a password between, let's say, I say we are using Cisco 123. That's a shared secret key between you and me. Now, that shared secret key has to be, there are two ways. It used to be like I call you and you call me, or I text you or you text me and I tell you this is my key. If you get my message, use that key and your message will be de-encrypted. Okay, but now you want to avoid that kind of hassle where you are manually exchanging that key. You will be using Diffie-Hellman protocol or a method, exchange method, to share that public key. So that key is also secured as well. Diffie-Hellman ensure that whatever the keys are generated, agreed, let's say, they will be also use the exchange method. This is the exchange method. The secure protocols such as SSL, transport layer, TLS, and SSH, and protocol IPsec use Diffie-Hellman. So they all use Diffie-Hellman to actually share the secret key. Agree on the parameter and generator, generate a private key, okay, based on the information, calculate the public key, and then exchange the public key. So you see this? Exchanging the keys actually over the internet, we use Diffie-Hellman. That's a method, exchange method we have defined. All these protocols, SSL, TLS, SSH, and IPsec, okay, they all use Diffie-Hellman protocol.
Might be a question.
Yeah? Please.
No, what I'm asking is whether this would be one important topic that can be asked in the exam as well.
Yeah, into that. There will be full detail about different groups once we discuss that, right? At just level, just giving you some information. AI Jamal, this is used by the US government standard for digital signature. Its algorithm is free because no one holds the patent. Okay. This crypto method uses elliptic curve as part of the algorithm in the US National Security Agency using ECC for digital signature generation and the key exchange. So mostly on the internet, this is mostly, you can see this is used by the US government, two of them, last two. So let's just discuss the difference between the symmetric and the asymmetric comparison. So the symmetric encryption system are more often efficient and can handle more data. However, key management with the symmetric encryption system is more problematic and harder to manage. So basically, if you are sharing a large amount of data, you will be better to use the symmetric actually key method. Asymmetric cryptography is more efficient on protecting the confidentiality of a small amount of data, and its size and speed make it more secure for tasks such as electronic key exchange, which is small amount of data rather than the encrypting large bulk of data. Okay.
A large amount of data should be the symmetric.
Yeah, better to use. It's just like some use cases, in which case you just comparing them together. Application. These are the application, both are the symmetric. There are many applications for both symmetric and asymmetric. A one-time password generated token is a hardware device that uses the cryptography to generate a one-time password. A one-time password is automatically generated numeric or alpha string for the character that authenticate a user. So basically, you know, some companies are now giving you a hard token or a soft token on mobile, installed on mobile. Every time if you log into your website, you might be using all the time same username and password. But if somebody knows your username and password, you know, he can log into your system. But if you use a two-factor authentication, okay, or one-time password, which means every time you need a new password, okay, which password will be changed after 30 seconds. Okay. The payment industry, for example, use 3-days operating system using 3-days file and system data with a password. Also, 4 other protocols use asymmetric key algorithm. IKE, which is a fundamental component of IPsec, we'll discuss in detail. SSL, which is a means of implementing cryptography on the web browser, SSL. SSH, which is a protocol that provides a secure remote access connection to remote devices. And PGP, which is pretty good privacy, which is a computer program that provides cryptographic privacy and authentication to increase the security of the email communication. So secure email communication, if you want to use, you can use PGP. And these are the symmetric or asymmetric encryption we can both use for these applications. IKE, which is usually for use for IPsec protocol, SSH, and PGP. So they all use these symmetric or asymmetric encryption method. We discuss that. Okay, we'll discuss in detail later on.
For example, normally in the organization.